Hello all of you, warm welcome. Today we are looking at another LeetCode question, which is word ladder, and this is being asked in January second week, second question. Now if I look at this word letter, this is uh, a hard level question in LeetCode, and it is being asked in Amazon, Google, Facebook, you name the company, and it is being asked because of the complexity it carries. So let's talk about what this word letter problem statement is all about. So we are given two words, begin word and end word, and a dictionary word list. Return the length of the shortest transformation sequence from begin word to end word such that only one letter can be changed at a time. Each transformed word must exist in the word list. Right. So so let's see the example, right? So I am given a word hit and my end word is cog. So I need to see how I can change the characters in this hit value so that I can convert to cog, right? And whatever conversion which I'm going to make has to be part of this word list. So if you see this example, right, it says let's take this and put it into my notepad. So this is what is given to me. So I need to convert hit to cog. Now there are multiple ways. Now hit can be converted to, if I look at that list, hot. Look at T, there's nothing as such, right? So this is the only one conversion. Now I have hot in my list. Now if I look at hot, I can convert it to dot. I can convert it to lot, right? Now I have two things again in my bucket. I have dot, I have lot, right? Now dot can be converted to dog, right? That's it. Or it can be again converted to log. And lot can be converted to log because I'm converting T to G, right? Now, if I look at it, I have new words which are log and dog. And now dog can be converted to cog. Similarly, log can also be converted to cog. And this is what they did also. So if you see this sequence, right, sequence of events which is present here, they converted hit. So they converted hit to hot, then hot to dot, then dot to dog, and dog to cog. Now it's important to see the number of steps which is being taken here. The number of steps are 5. So we, out of all these combinations which we are seeing right now, we have to send out whichever is the minimum number of, you can say, iterations which will land up us being reaching to cog variable, right? I think you would have understood the question by now. Now how are we going to approach this problem? So if you look at it, right, so if you see these mappings here is as simple as if I look at these are nodes which are being converted to these nodes, right? And let's picturize this like this, okay? Hit can be converted to cog, so hit can be converted to hot, hot can be converted to dot, and hot can also be converted to lot, right? uh, Let me see if I can use a tool to kind of picturize that. So let me use paint. So I have hit, and then it can be converted to hot, right? Now my hot can be converted to hot can be converted to dot and lot, dot and lot, right? And now my dot and lot can be converted, dot can be converted to dog and log, right? So what it will convert it to? It can be converted to dot can be converted to dog and log, right? So it can be converted to log and can be converted to dog, right? And if we again go back and see what lot can be converted, log can only be converted to lot. So that is again this being compared to this one, right? And now these two can be converted to the output variable cog, right? So this is a graph, if you can see, right? This is, if I remove this, right? If I remove this, it's a non-directed graph, right? Wherein each word is connected to the other word by replacing only one character in that particular word, right? Now how will we approach this problem? So we will, so first we will do, right, if I write a pseudo code to it, we will first create one list. That list will be, say, a hash map, hash set. It will contain all the words in the list, which is here in this case word list. Now what we'll do is we'll create a queue, right? What will queue do is, it will, you can assume that to be a list which will contain the next set of nodes, which will keep on, we will keep on adding the number of nodes which are going to come, and work on that node, in the iterations. So this queue will contain word combinations as such, and we will keep on updating it. So assuming I will just add first word into the queue, and then I will see, okay, what all can be retrieved out of that word, and whatever I can find, I will go and add that into the queue, and I'll work on those queues as such. So if I give an example, first I'll add hit, I got hot, I'll add hot, then I'll work on that hot, as I'll get dot and lot, I'll add these two, then I'll work on dot, then I'll add dog and log, and so, right? Then what we'll do is, we'll again say create another variable which will be just a tracking list hash set. That will be again a hash set, which will be tracking hash set, which will ensure that we are not repeating the words, because we are going to keep on replacing each character at a time, right? Now the very important step, right, because we are going to change one word at a time, what we're going to do is, if I have hit, right, and I'm supposed to change one word at a time, I'll first go ahead and change the first character of that word. So, and how will you replace it? We'll go through each and every character which is present in the English alphabets as such. So I'll convert it to AIT, BIT, CIT, DIT, EIT, and so and so. And then what we'll see, we'll check if any of these words are present in word list. If yes, then we will add it to the queue and update it to be visited, and we'll work on that queue, right? So what will ensure it, somewhere down the line when I'm going to in this if I just change hit, I'll not find anything, right? I'll go and then what I'll do is I'll take the next word. Now what we'll do is now it will change to HAT, HBT, HCT, HDT, and so and so. And here we'll find hot in the between that will present. So in this case, add hot, right? I think you would have got the idea by now what I'm trying to achieve here, right? Dot, right? These will be added on those lines, right? So let's code it now. So as I said, right, first we'll create one hash set, which will be of string format, which will be a word set, and then what is always going to the next line, right? Right now what we're going to create, we'll see. Okay, very first basic check, right? Because it's saying that okay, if this word is not containing that, right, dot contains end word, if it doesn't contain the end word, then and there's no need to do anything, just return 0, because we don't have the end word in the first place, so there's no need to iterate the and do the entire logic in the first place. Now what we'll do is we'll create a queue, which will be again be of a string format because we're working on strings. String, right? Now what we'll do is we'll create, as I said, right, another hash set which will contain the visited values, that okay, whether we have visited a given string or not, right? Now I have everything. I have all the variables. Sorry, one more thing, counter, right? Count that, okay, how many, where are we standing in terms of finding the given value, right? Now what we are going to do is now we are going to add to the queue, right? So we'll do queue dot enqueue my first word, which is begin word, because that's where my whole iteration will start, and I'll say yeah, this is a visited value, right? So that I don't go ahead and try to add this back into the queue, and if because if we end up doing that, then it will be an infinite loop and we'll never end the queue, right? Now what we'll do is we'll see, okay, work on this queue until unless it is greater than 0. I'll work on that queue, right? Because I'll work on each and every queue value, and I'll try to find all the words which are going to be present in this one, and I'm going to keep on adding on this queue while we are going to iterate this, right? Now what we'll do is we'll iterate through this queue, right? Uh, we'll iterate through this queue, so this will be like queue dot count I is greater than 0, I minus minus, any type of, we can take 0 and that also will be fine. That's it, just that we need to run on this queue, right? Now it will say okay, fetch the current word which I'm going to work on. So what are the word which I'm going to work on? That will be queue dot dequeue this time, right? Now I got the word which I'm going to work in this iteration. This is my current word, right? And I'll say okay, yeah, if this current word dot equals my end word, if it is to just return count plus 1, because that will be my, because that's the next step which led to reaching to that end word, hence the count plus 1. Otherwise I'll just create a char array, or say current word array for that matter, which will be, because see, as I said above, right, will convert all the words into the subsequent conversion by changing one letter at a time, right? So I'll convert this into a char array and I'll keep on replacing one alphabet at a time, one character at a time in that array, right? Now what I'll do is I'll iterate through j is equal to j less than current word array. See, this kind of where, because if you see this is I think I missed it. What we are doing is right now breadth first search, because if you see this example, right, we are going and looking at all the neighbors to a given word and trying to see whether it is an end word or not. If not, then we are going to find the next neighbor to it, right? So if we are looking at this kind of a problem statement, then definitely here we will need to have these loops so that we can look for the neighboring nodes as such, or neighboring words in this place, and try to find the matching value, right? So dot length j plus plus. So I got all the characters. So if I do correct, if I look at hit, for example, h will be my first character, right? So if I original character in this place will be h, so that will be current word array j. So I'm storing this into a value, so that because I'm going to change this value with my next iteration. How I'm going to change that is I'm going to create a char array which will run till it is equal to z, and what I'm going to do is I'm going to replace this current word array with that ch, right? If you see this example, if I'm looking at hit, sorry, I wrote it here. So if I look at this hit, it will change to AIT. So I'll replace A, then B, then C, and so and so. Right now this got replaced. I replaced it with CH. Now what I'll do is I'll convert this new kind of char array into a string. So I'll just convert next word, whichever I'm going to find, is equal to new string current word array, and what I'm going to see if this is visited or not, because idea is it should not be visited, right? And it should be part of my word set as well, right? Then only I'll add it to the queue, right? Because I'm going to work on this word now, and I'll also say, yeah, this is visited, right? This is done, right? I iterated through all the characters and saw whether it is doing anything or not. Now if I come out of it, right, what I'll do is I'll mark my current word array back to its original value, because I don't want to miss out the original content to the given word, so that when the next iteration happens it's still intact. Because when I'm going to do the next iteration, I'll have to work on I, so my h should be intact, it should not be replaced, it has to come back to hit back again, right? Now once my this iteration is done, that means I worked throughout the throughout the when once my this iteration is done, that means I worked throughout my current array, right? And when my this iteration is done, what I'll do is that means that particular neighboring nodes calculation is also complete. Now I'm moving to the next set of nodes. That's where it will become count plus plus, right? What I mean by that is, that means I come I have completed this segment, right? I'm moving to the next segment. Hence, this will become, so counter which was 1 here, counter which was 1 here, it will become 2 here, right? And 3 here on those lines, right? Right. Now, this will do return count plus 1 the moment I get the end word. If nothing happened, I'll just return 0. Right. So let's look at three once again. We created a hash set which will contain the number of words. We created a queue. We created a visited hash set. What we'll do is we'll keep on adding the words into the queue and always mark them visited whenever we are adding into the queue. We'll iterate through each and every queue variables and see whether any we'll iterate through all the words which is there in the queue. Then we'll go through each and every word and convert it to all the combinations which it can carry, and then whether we'll see whether that combination is part of my hash set or not. If it is present, then I'm going to keep on adding into the queue until and unless I'll find the end word. Until unless I find the end word, right? And if nothing of this is kind of succeeding, then I'll just return 0, right? I was not able to find anything, which will not happen in this scenario because we have anyways taken care of that in the base place, right? So ultimately it should always end up in this line statement. Let's run it. I got a compiler error, C does not exist, line 40. It's going to be ch, and I got another error which was line number 15, generic hash t requires line number 15. Oh, sorry, so this will be again a string. I missed that. Again a C problem, line number 40. Oh, sorry for that. Okay, so I think I missed adding that wordlet in the first place, which I'm working out in the bottom arrays, because that's what I'm looking at, whether it contains or not. So let's see. Okay, nice. That was the issue. So I missed adding the word list into the hash set, resulting to always getting the 0 error because this was always failing. Wait, let's try to submit it. It got accepted, right? So let's look at time complexity. So if I look at it, right, we are always going through each and every word which are present in the word list, right? And then we are also going through number of characters which are there, right? So one is the number of words, right? Now that is being multiplied by 26 number of characters, and then we are also going through each and everything into the queue as well. That means whatever the maximum length of the queue will be, so that will again be equal to n. So that is your time complexity which we are looking at, this one. Okay, so this is it, guys. Subscribe the channel for any upcoming videos as such. Thank you, guys. Thanks a lot.